So we have seen the less common handover in blind handover, in interfrequency handover, which is blind handover. But the most common interfrequency handover is based on measurement. So again, for the measurement, for interfrequency measurement, it needs the triggering factor, where the triggering factors, it varies based on the handover type. So we are using coverage-based handover as an example, where the user report event A2 to trigger interfrequency measurement. So if the user sent the event A2, means the user will be assigned a measurement gap. And the user will be measuring the neighboring cell, and by sending the report, by default, event A4 is used. User will stop measurement if the event A1 is met, means the user sent event A1 to stop the measurement. So during the measurement, it is called gap-assisted measurement, and the reporting mode is also event-triggered periodical. Event A3 could be used for coverage-based interfrequency handover, whereas for the other type of the handover, it has to be selected between event A4 and event A5. Then based on the report received, eNote B decides if a handover should be performed. And then again, the candidate cell filtering and ranking will be performed, and the data forwarding will be done via S1 or X2 interface. eNote B performed the handover after by sending the handover request, and the target eNote B has to perform the admission control. Then a retry mechanism will be done if the first candidate cells reject the handover request. So retry will be attempted in the next candidate cell, which is in the same measurement report. So this is a command for us to configure the measurement object. As we have mentioned earlier, measurement object means the frequency, which include the frequency number, frequency offset, the antenna ports, and the neighbor cell configuration. So to trigger coverage-based handover, we are going to have a look on the coverage-based handover first. Coverage-based handover is triggered by event A2. That is, the user sent event A2 when the serving frequency with the hysteresis is lower than a specific threshold. So the user will be entering into measurement gap, and the measurement gap will stop when the event A1 criteria is met, means the serving frequency minus hysteresis is greater than a specific A1 threshold. Then this is where the user stops the measurement gap. This is a screenshot to activate and deactivate the measurement gap. The activation is called measurement gap config. So measurement gap config is for a measurement. Then when the user sends event A1, a measurement gap will be deactivated. So measurement config, which is to release the measurement gap. So when the user is in the measurement gap, the user is constantly measuring the other frequency or IRAC. For coverage-based scenario, the reporting mode could be selected from A3 or A4 or A5. But for the other scenario, only event A4 is used, and also event A5 could be considered, where A5 include A2 plus A4. So we are going to have a look on the difference between A3, A4, and A5. So we have seen the formula of event A3 earlier, which means the signal of the neighbor is greater than the signal of the serving. With the only difference is, now in this case, this is interfrequency handover. So OFN is not the same with OFS anymore. So OFN and OFS plays, it does affect the handover decision. As for event A4, that is to compare the signals of the neighbor with a specific A4 threshold. So it means the MN plus the OFN neighboring frequency offset, the neighboring CIO and hysteresis is greater than a specific A4 threshold. So user will leave A4 when the neighbor is worse than a specific A4 threshold. So A2 indicates the signal of the serving cell is worse than the threshold. Where A4 indicates the serving, the neighbor cell signal is greater than an A4 threshold. Where A5 simply combined A2 with A4, which is the serving cell constantly remains to be lower than the A2 threshold. At the same time, the signal strength of the neighbor has been greater than the event A4 threshold for at least for time to trigger time length. So as for the other type of the handover, we have finished the coverage-based handover, which is triggered by event A2, and the user is measuring the signal of the neighbor, and the report could be in the format of A3 or A4 or A5. So what about service-based measurement trigger? Service-based measurement is triggered right after the user initiate a predefined service, which is usually the VoLTE service. So right after user initiate a VoLTE service, the init B have found out that there is only one EREP assigned to the user. So init B assigned the measurement gap to the user. So the measurement gap will be sent to the user along with the measurement configuration of interfrequency. So the user measure interfrequency signal, and only event A4 could be used for other type of the handover. So the user will be reporting the reports if the neighbor cells fulfill event A4 criteria. So based on the reports received, init B make a decision for the handover and to move the user to a dedicated frequency according to the service. So we have to define the service-based handover according to QCI. QCI stands for QoS class indication, which VoLTE is represented by QCI 1, class 1. So, for example, we can actually define QCI class 1 to a service-based interfrequency handover policy group 1. So with the group 1, the policy means that this particular rep, this particular service is allowed to perform handover, permit handover, and with the handover is to a specific LTE frequency. So this is the configuration which we could be done. And the service-based handover measurement will stop if there is no trigger after 3 seconds of the gap. So it means if the user has been entering in the measurement gap and it lasts for 3 seconds, but there is still no handover trigger, then the measurement will be stopped. So the parameters in the measurement configuration for service-based, they are all exactly the same with the coverage-based IRET handover. So we are using event A4, where the RSRP and RSRQ threshold for the event A4 will be used. So we have just finished the handover types of the service-based handover trigger. And from the next page onwards, we are going to look at the other handover types, which including frequency, priority, distance, and quality-based handover.